This could be the most valuable class you've ever taken, because the learning outcome from this class is that ChatGPT in the hands of a person who doesn't know what they're doing is completely useless and will destroy you. Meaning you're going to get a job, and for the first week you can use ChatGPT, and then in week 4 you're going to get fired. I would go and I would see students come in and they would bring me code that clearly came from ChatGPT, right? And I would ask them like, well, did you watch the lecture? Yeah. Of course I watched the lecture. I said, well, did you look at the sample code I provided? And it doesn't take long for me to like just figure out, because ChatGPT writes beautiful code. It's syntactically correct. It uses some of the more advanced features of any library or whatever. And so it's like, I look at it and go like, nicely done. And then I realize, oh, wait a sec, I'm complimenting ChatGPT.
Yeah, I think the thing I'm thinking about is like in the real world, when you might be able to cheat through the exam. And I like your example, but I've seen it like in the field where people will cheat on other exams. So they find all the answers, they memorize the answers, but they don't actually know how the stuff works.
Yeah.
You're going to get caught out somewhere, perhaps on the interview, but perhaps actually in the job. So you're harming yourself by cheating like this. It goes through the pain. It's like I think it's really important to do that so that you actually learn the skills, right?
I do think that a lot of teachers build really horrible classes. Well, so the Path to the Master Programmer is effectively my personal curriculum that would replace a computer science degree if your goal is to become a programmer.
Hey everyone, it's David Bommel back with the amazing Dr. Chuck. Dr. Chuck, great to have you back on the show.
It's great to be back on the show. We always have so much fun.
It's so nice to get your experience and your advice. And it's 2025 now. And I think a lot of people in this new year are going to want to know, firstly, is it worth becoming a programmer? Because, AI is eating all the jobs, some people say. And then secondly, how do I become a programmer? So perhaps we can start with the AI question and then you can take us on a journey.
I see AI through kind of a couple of lenses. One is just kind of a hype listener and I want to discredit the hype. I just am tired of it. And I'm tired of no company has any new ideas except AI, right? Whatever they were doing, it's whatever they're doing plus AI. But the other way I see it is through my teaching. And so from the moment AI started, me and my other colleagues at the University of Michigan School of Information were vowed not to be anti-AI, right? To be pro-AI, because we feel like if you're not pro-AI, you're not helping the students, right? And so many of us try to design AI usage into the class. Mm-hmm. And so we don't prohibit it, but then we have to warn students, right? I mean, we're taping this at the 2/3 point of our current semester. And this is where I'm starting to get email after email after email from students who are like, I'm just falling farther and farther behind in this class. I mean, every week I can't keep up and in the last 2/3, but in the middle third, I would go and I would see students come in and they would bring me code that clearly came from ChatGPT, right? And I would ask them like, well, did you watch the lecture? Yeah. Of course I watched the lecture. I said, well, did you look at the sample code I provided? And like, yeah. And like, well, could you show me the sample code that you were looking at that you used to adapt to make the code you wrote? Yeah. And it doesn't take long for me to like just figure out, because ChatGPT writes beautiful code. It's syntactically correct. It uses some of the more advanced features of any library or whatever. And so it's like, I look at it and go like, nicely done. And then I realize, oh, wait a sec, I'm complimenting ChatGPT. But the simpler and the more elegant and the more advanced features that a student uses in their early applications, the less they understand about what's going on. They're just like, oh, please help me, ChatGPT. These students are going to end up with a B or C in a class. I'm just about to send them a letter that says, if you're feeling this because of ChatGPT, you should just resign yourself to getting a B or a C in this class. And with grade inflation, getting a C in a class is like, my parents are going to come and revoke my allowance because I didn't get an A. And so I'm at that point where there's no chance for these students to catch up. And it has to do with the following. There's this concept called the zone of proximal learning. And the idea is I have 15 weeks, and it's kind of in thirds. The first third, the assignments are designed to create a sense of confidence and success in the students. Like, look, you can do this. You got to learn how to read this and here, but I make sure you don't fail. I give you lots of very explicit instructions. And then the middle part is where I'm trying to transition you off me giving you too much. I call it the DIY part of the class, where they're supposed to kind of start not depending on my descriptions of what to do, but instead think. And then at the end, I teach them a bunch of stuff. And the whole first 2/3 of the class is so that they can be successful in the last third of the class. And what I'm trying to do is I'm going to make it each week, I try to make a challenge that they can achieve. And so like first week is a challenge that's small and they can achieve that. And the second week is next, and it starts building. And pretty soon they know quite a bit. But the other problem is in the first third of the class, ChatGPT can usually crush my assignments. And that's not because I designed them to be crushable by ChatGPT. It's just I made very, very explicit things using language. And what does a large language model do? It reads my instructions, goes, I figure out what this guy just said. Not just because ChatGPT, but because it's necessary for learning. In the middle third, I start making my descriptions more vague. And that's not just to confuse ChatGPT, although it does confuse ChatGPT. It's to get them to actually like go off on their own and research and look at the shorter descriptive sentence that says do this by looking at that, not here's what you paste in. And this is where ChatGPT starts getting lost, because it's like we're gonna build an application to track pets. And then you give that to ChatGPT and goes like, here's an application that tracks pets. Well, it has nothing to do with like how I wanted you to write the application or what the data model was supposed to be. But it's like, I know how to build an application to track pets. And so they walk in with these ChatGPT generated things, and they have taken it to their friends. They've taken it to their buddies in computer science, and nobody quite knows what to do with this code that they think is half done. And then they come into me and I can't help them. I mean, every once in a while I say, well, here, put those 4 lines in and you'll be okay. And then they go off and they think that week is done. But really what happened is they walked away from a struggle that was a struggle that they could succeed in. That's the zone proximal learning. As I'm like, I make a thing and I know how hard it is to go up. So I make the steps small and small and small. And so what happens is that ChatGPT starts to lead them badly astray in the middle of the class. And then in the last part of the class, the steps get really big and the assignments get really vague. And ChatGPT has got nothing. I mean, they can't even kind of get a half-broken solution from ChatGPT in the last third, but they have gotten kind of halfway through the class on ChatGPT. And that's the problem.
Yeah.
And I'm going to send them a letter, and this letter is going to say, you depended too much on ChatGPT in the beginning of this class, and so you started to fade away in the middle of the class, and you were incapable of doing the stuff at the end of the class, but you did okay on the exams, and so you'll probably get a C. This could be the most valuable class you've ever taken, because the learning outcome from this class is that ChatGPT, in the hands of a person who doesn't know what they're doing, is completely useless and will destroy you. Meaning you're going to get a job, and for the first week, you can use ChatGPT, and then in week 4, you're going to get fired, right? So if you think that ChatGPT is what people are hiring you for, and then there's kind of this other fallacy, because I don't teach computer science, so we talked about this a bunch, right? I don't teach a canonical kind of curriculum the way computer science does. Now, the interesting thing in computer science is that ChatGPT can support you, in my opinion, far longer in a computer science curriculum, because the highly described but very difficult problems are something ChatGPT has seen a million times already. So you can be at week 12 of a first computer science course, and ChatGPT is like yummy, yummy. And so you can get farther in computer science than my class, because I'm consciously becoming vague, and my stuff there's not 10,000 universities that teach the exact same set of 15 assignments that ChatGPT knows about. But the point is ChatGPT is going to AI is going to let you down. And then I juxtapose this with talking to my teaching assistants. We have lunch every Friday. And I'm like, what are you up to? And like, how are you using ChatGPT? And like my teaching assistant said, well, I'm saving a lot of time as I'm trying to help students with small typos in their program. I could either look at all their code, but what I've done is I've gone into ChatGPT and I've described the problem and I put in my solution to ChatGPT and say, this is the problem we're working on. And here's some code I wrote, and here's this and here's that. And then what they do is they grab code from the students and they start feeding it into ChatGPT and say, this is close, but not quite right. What do we got to fix? And ChatGPT goes like, missing semicolon line 207.
Yeah.
So this is a person who is a master of the material, who is using ChatGPT like a sword, right? And that's the problem, is ChatGPT is going to be great. And it's going to accelerate people who know what they're doing. And it's going to cause people to drop out of programming. So one of the things that I'm fighting with all the time, I've fought my whole career, is how do you get to the point where people don't drop out at week 7 of their first programming class? How do I make a more gentle class? And I've been very successful at that. Computer science hasn't sort of fixed themselves. They always don't care that a lot of people drop out because they don't want to graduate so many people. I want to graduate as many people as I can, so I make the classes more tractable. And the problem is that with ChatGPT, we're going to get back to a situation where people drop out. They start in a programming class, and this programming class is designed for them to not drop out, right? For them to achieve, to not be sorted as a thumbs up, thumbs down, like, sorry, it's week 5. You shouldn't be a programmer. Go away. Work in the fields and pick potatoes because you are not worthy of programming. And the answer is no. Everyone can learn to program. It's really easy, except now ChatGPT is ruining it, right? Because if you are gentle and you give people a gentle introduction, they can use ChatGPT too much to bypass the early learning experiences where like, oh, aha. No, it's not. They're in a hurry and they don't get any aha moments. They don't get any early learning. And then they encounter the first situation that ChatGPT can't do the work for them. And they decide that they're not a programmer. And the answer is ChatGPT led you down a path of very bad choices. And now you're going to drop out, and it's because of ChatGPT. And so that sort of breaks my heart as a teacher, that I've been trying to solve the problem of people getting halfway through a programming class and dropping out because they feel that they could never do it. And I don't know what to do. I'm starting to think about having whole lectures on what we're just talking about, like a diagram of the zone of proximal learning with these blocks of different heights that talk about, like, this is the moment where you're going to be in trouble. If ChatGPT can't take you beyond this point. So you should be careful using ChatGPT. And so I'm not going to give up, right? I'm a teacher, and ChatGPT is now a problem. It's not a problem for me. It's a problem for the students harming themselves using ChatGPT. And so how can I teach them not to do stupid things with ChatGPT and how to feel the struggle, feel the success from the struggle? Yeah. Again, I've been teaching so long. I get email from people who are writing 4 lines of code that any programmer in the world would be able to write in 5 seconds. And they're struggling with it. And I'm like, love the struggle. Love the struggle. Don't just get the answer, just love the struggle. And those are the ones that ChatGPT helps. I think we're going to find a situation where this new AI capability is really going to sort of have some kind of flame out effect, meaning that fewer people will know how to program and therefore know how to use ChatGPT. And so guess what? Learning to program and learning how to use ChatGPT wisely while you're learning to program is going to turn out to be a mighty good skill. And there's going to be fewer people because all the people who just use ChatGPT to pretend they're programmers aren't going to be in the job market. They're going to have to go work in the fields, picking tomatoes under 100 or 35 degrees centigrade sun. So it's kind of weird that I've spent the past 10 years of my life trying to bring as many people into programming as I possibly could. And now ChatGPT is going to defeat me, or defeat me in some ways, that says I can't keep bringing more people into programming because they'll use ChatGPT and then they'll fail because of it.
I mean, we've both been teaching for a long time. I mean, it's in the old days before this existed, people would use brain dumps or just cheat in other ways. But you're cheating yourself by doing that, right? Because you're not learning, you're not going through the journey, like you said, you're not going through the pain.
Yeah, and so, I'm a big actual fan. One of the things on my tests that I do is I give you cheat sheets, right? So my tests are kind of weird. My tests have multiple choice questions and short answer questions, and they're all on paper because of ChatGPT, right? But here's the thing that I do is I give quizzes in between each exam And I tell them that I'm going to use the exact same questions from the quizzes on the exams. And I give you 2 pieces of cheat sheet paper. And you can kind of guess what a lot of students are going to put on half of their cheat sheet. They go and they grab all the quiz questions and they remember the right answer to all the quiz questions. And that's half their cheat sheet. So you might say, well, Chuck, why are you even doing that if you let them have a cheat sheet? And I'm like, that's called studying, right? I mean, there's some chance that in the preparation for that exam, they still have to read the question. They have to understand the words on the question. They have to read all their cheat sheet. And so I'm like, you're learning, right?
Yeah.
And so I don't try to make really difficult exams. They turn out to be as difficult as the student wants to make them, depending on how much they study. And so the notion of brain dumping and cheat sheets and whatever, you're right. That's been forever, but a clever teacher uses that to their advantage and uses that as a moment to get their attention. So to me, exams are just to get students' attention. They're just like, okay, you've been kind of bringing half effort for the last 5 weeks, but now this week you got to think about this class or you're gonna bomb this exam. And then they all do pretty well in the exam, which makes me happy.
Yeah, I think the thing I'm thinking about is like in the real world, when you might be able to cheat through the exam. And I like your example, but I've seen it like in the field where people will cheat on other exams. So they find all the answers, they memorize the answers, but they don't actually know how the stuff works.
Yeah.
You're going to get caught out somewhere, perhaps on the interview, but perhaps actually in the job. So you're harming yourself by cheating like this. It's goes through the pain. It's like I think it's really important to do that so that you actually learn the skills, right?
I do think that a lot of teachers build really horrible classes. And I think we talked about this before, that if you're encountering a really hard class that is expecting you to do 100 hours of coding per week for 1 point, if you come up with a quick and dirty way to short circuit that so you can get some sleep as a student, I'm not very judgmental at that point, right?
Yeah.
So my contribution to their learning, I build a class that is not going to destroy them, not going to take away their whole sleep for 15 weeks. And if they are willing to struggle for an hour or 2 every week, I will reward them with true learning. And so I think there's just too many classes that are unnecessarily difficult. And so this kind of by any means necessary mentality sort of percolates, and away you go.
So, I mean, it's interesting because in the previous interview that we had, you spoke about the problem where students were submitting code or you were seeing code and the problems were hidden so deep in the code because it was written by ChatGPT that this is a problem in the real world, right? If people rely too much on AI, and we keep saying ChatGPT, but I mean AI in general, there's going to be vulnerabilities in the code. There are going to be other problems in the code, and because they don't understand it, it's going to be bad coding. But here you're also talking about the fact that ChatGPT is stealing their future basically because they're relying on ChatGPT or AI, whatever, instead of learning it themselves.
I think when you're talking about the ChatGPT embedding bugs deep in code, you're not talking about my students. You're talking about a story I told about me.
Yeah. Oh, okay. Yeah,
that was me.
I can't remember if it was a student or it was someone.
No, it was me.
It was you. Yeah, that's right. Yeah, I remember.
It's a patch that I wrote for Sakai that I hoped would be right, and I didn't look close enough. And it introduced a regression that we found in 24 hours. And I had argued with people about the fact that I was sure it was right. And they were like, I don't know about that. And then they were right. And I had to kind of like go back and like, you were right in my use of chat. So think of that like a job situation, right? I mean, I'm a volunteer, but I mean, I'm sitting there with my team code reviewing and trying to convince them that this code that came from ChatGPT is suitable. And then they listen to me because they like me and they let it in. And then like 24 hours later, it regresses and crashes and I'm having to apologize after that. And so, that was that story but that's more of a job story, right? You're going to bring in some ChatGPT stuff into something you're paid to do as a professional, and you didn't look close enough at it. And now you're going to lose the company $100,000 of revenue. And you're going to eventually realize, or someone else will realize, that the code you put in had a tiny mistake. And when you finally have to admit that I didn't look at that code because I was so sure that ChatGPT was right, that is an ugly place to be. Okay, well, let me tell you one other AI topic. And I've been telling this to people. I'm curious what your thoughts are on it. I think that we are in the golden age of AI and things are going to get worse from here. And I'll tell you why. I think that everybody should archive the data they use to teach their model and archive their models, because it will not be long before AI is going to be looking and programming. The AIs of the future will be programming themselves from the results of AIs.
Yeah.
So let me tell you why AI works today. And that is that I can write a blog post about learner privacy, and you can write a blog post about learner privacy, and then a third person can write a blog post about learner privacy. We are humans with our best intention of being correct. And I make little mistakes, and you make little mistakes, and the third person makes little mistakes. But our mistakes are somewhat randomized. And so if you look at me and you and one more person, and you look at it closely enough, or maybe even more people, the mistakes tend to factor out, right? Because our mistakes are random, just because we're imperfect. If, on the other hand, AI is generating material, whether it's code or writing or videos or audio, AI is going to multiple AIs from multiple sources, going to take from the same kind of corpus, are going to make the same mistakes. So now you got AIs reading what they think are independently created piece of information using the standard error elimination through multiple sources, but all the sources will have made the same error. And let's just say that error is 1%. But now all the AIs that are reprogrammed in 5 years from a lot of AI generated data will have a 1% error rate that they can't fix.
Yeah.
And then the things that those AIs do is they generate a 2% error rate. And then the next generation reads in stuff that's got 2% errors. And what we know from sort of the law of exponents is 1.01 is infinity and 0.99 is zero as time progresses. And so I just think that people aren't thinking about the consequences of AI reprogramming itself from materials that came from AI. So let me give you a real simple example. I did a podcast, 5 years ago. I was really into learner privacy and learnerprivacy.org. I did this podcast, and I wanted to the podcast was supposed to have extremely high production values with lighting and scripts and music and all this stuff and a character. And I researched every one of those episodes of that podcast, and I did slides, and it was beautiful. It was like 7 little TED Talks. And I thought the world would watch my little 7 TED Talks on this podcast, and then they would listen to me and they would care about learner privacy.
Yeah.
And so I did all this work, and nobody cared. Nobody really listened. I still think it's really great work. So now AI wanders by and grabs my stuff and says, yummy, yummy, yummy. Reads all this stuff up, reads my source documents that I used to do all my research. I could tell AI right now, I could say, you know what, AI, I want to make some money off this learner privacy thing. I've got 7 episodes out there that are really good. How about you, every month, make up a new episode with cool lighting and cool video and the character and the tone, and pick some music and write the script and do whatever. And now this learnerprivacy.org, instead of having 6 or 7 episodes for the next 5 years, has an episode every month. So it's got 75 episodes in a few years, except only 6 of them were written by humans. But the world doesn't know. And the average viewer will be fine if there's little mistakes, but the AI won't. The AI will believe it was written by well-intentioned humans and use its same error correction. So all I'm saying is those of you who have data and AI models, keep them. The future ones are likely worse. Now, I'm not saying that we figured out all the applications of AI, right? I'm not saying that someone's going to build a really cool thing for helping software developers read documentation using AI. I mean, there's so many good applications of AI, but the core models themselves, I think, are going to start to decay as AI does more and more. So that's my, scary future view that they're just going to get dumber and dumber, and we're not even going to notice it.
I think it's a very valid point, because, like you said, it only takes a small increase, and then it becomes exponential as they're learning from each other and learn bad data from one another. I mean, I already see, when we're recording this, when Google or other search engines use AI to try and give you the correct information, it's so frustrating because a lot of it's just nonsense, even now.
Yeah, absolutely.
Dr. Chuck, I've got to ask you the big question, because a lot of people will be thinking this. Is it even worth me becoming a programmer?
Yes. Of course, it's worth becoming a programmer. And this is, you'll find I'm consistent on this. And that is the amount of core, deep, painfully acquired knowledge that you need to be a good programmer is decreasing. And so if you think about what is the minimum required curriculum so that someone is capable of being a good programmer, and we've talked about it before, the whole goal of education is not to teach you everything you need to know, but to prepare you to learn rapidly.
Yeah.
And now it's to prepare you to learn rapidly with the help of AI, right? And so the curriculum does not need to be any larger, right? Every student to be a good programmer does not have to write an operating system project, which wastes a year of your life. And so I think what we're going to find is that software developers are not going to need 4 years to be ready. And with AI, you're not instantly a software developer. I mean, you still got to struggle. You got to learn some basic things. But I think the important question for curriculum designers, myself included, is not to waste the students' time. Don't teach the stuff we taught. Don't just teach a compiler because we've always taught compilers. Don't teach operating systems because we've always taught operating systems. Figure out the essential things to prepare students to learn and grow and create in an AI enhanced environment. And so that's the key. The key is we, you kind of say, well, is higher education, less valuable? And the answer is, well, I think it's as valuable, but higher education as we currently think of it is less fit for purpose, right? But it wasn't AI that made the current sense of how to create software developers not fit for purpose. It's just software is getting easier and has always been getting easier. And AI is just one more step in the, wow, it's not as hard to be a programmer as it once was.
So will I be replaced by AI? Or it's kind of the similar kind of question, right? I think the fear is AI is going to replace me, so I shouldn't even get started becoming a developer or programmer.
That's a great question. I actually talked to lots of students, and I talked to a young lady at the Apple store. She had just graduated, and she found out I was a professor, and she was asking whether she should go get a master's degree because she didn't get a job, right? She'd been out of school for 6 months, and she didn't have a job. She did interviews, didn't get them. I think there's a different question. I think that you're going to have to get an education to be worth getting a job. I think what's going to happen is the number of $200,000 a year jobs for just having a computer science degree is going to rapidly approach zero. There's two factors that are affecting that. And let's go to the TLDR on this though. The TLDR is salary expectations for software developers are going to go down. And I wouldn't be surprised if Cisco and network engineers, the expected salary is not as high as relative to the inflation as it was, say, 10 years ago, right? The more we teach,
that's true.
The more there are. And so instead of expecting that you get a computer science degree for your computer science degree and you get a yacht a week later because of stock options, we're going to find that software development is a job. It's just a job. And hopefully you'll get benefits and you'll get decent pay and you'll be able to, have a place to live and raise a family if that's what you want to do and have some dogs and go to Portugal in the summer. And, you'll be able to enjoy your life, but you're not immediately going to own your own island just because you know C++. And I think that's part of the society and a part of education that we got to figure out. And that is that programming jobs are no longer these top of the mountain guru kinds of jobs that are super highly paid. So with the assumption that developers are not going to be paid astronomical amounts of money, it's another career choice. And I think it's a wonderful career choice. It's a career choice that doesn't require you to be out in the snow digging. It's a career choice that doesn't require you to get up at 5 o'clock in the morning so you can drive a snowplow. And there's a lot of reasons to love it. It is a very satisfying, the stuff you've done over your life has been very satisfying. It's safe. You're out inside and air conditioning and you get to go home to your family and you feel like you've done something creative. I mean, I got into this because it was creative, not because I thought I was going to make $200,000 immediately. And it was fun and it was joyful. And I think we got to get back to that. But then there's this other side of that. And you say, well, why did that happen? What happened? And I think there are two things. One is we've gotten better at teaching programming and we have more of them. And just like CCNA, there are more CCNA people now. Yeah. And so that means the supply is there. But in particular, and tell me if this is true in CCNA, the problems that very wealthy companies need to solve are not as hard as they were 15 years ago.
Yeah, a lot of it's been solved. Yeah.
And so if you kind of imagine that you're Amazon and you're raking in a ton of money and you want to like say, man, wouldn't it be cool if I could just have a bunch of servers that were virtualized and I could just make money by giving a person for $12 a month a fractional piece of this little server that cost me $1 a month. That's a pretty good deal if I can sell something that costs me $1 a month for $12 a month. And if I can do that 1 billion times, well, that's $11 billion a month, right? I mean, it's really easy to just stack up computers and do it. And so if you imagine what that was like in 2000, when someone imagined that they're going to sell fractional parts of computers to people, you would say, oh, wow, there are so many hard problems to solve. I need like 10,000 PhDs. I need 40,000 undergraduate bachelor's degrees. And I need 8,000 UI UX designers. And I need 3,000 documentation writers. And I need 1,500 QA people. And I need whatever, because this is a hard problem. It's like building a rocket ship, right? And every little bolt on a rocket ship is hard to build. So companies like Amazon took their prodigious revenue and created these moonshot software development activities. And, you know, as they developed it, people did things like built Docker. Mm-hmm. And they're like, if you'd have like time traveled back in time to 2000 and showed people Docker, they'd be like, yeah, that's never going to happen. That is such a hard problem to solve. It'll never be solved. No, computers are so hard. Forget the whole Docker idea. It's a dumb idea. Virtualization, no way. Not going to happen, right? That's too hard. And so not only did wealthy folks solve it, then like cheap imitation solutions like Docker and other virtualization mechanisms made it available so you can have like a server room in your house and you can subset your little CPUs to whatever things you want to do and have 12 virtual servers like just sitting on your dresser and use an open source software, right? But once you're done with that, that was foundational research in hardware, in software, in performance, and iteration after iteration after iteration of let's try this. Oops, that was good, bad. Oh yeah, that was good. Then let's try this and try this. I mean, billions of dollars of iteration. But then ask yourself, forget AI for the second. Ask yourself, Google, Facebook, like Facebook, no SQL, the entire sense of how to scale a database. We had $1 billion spent on NoSQL databases, which in my opinion are a complete waste of time because the whole NoSQL experiment was nothing more than improving the understanding that relational databases had about how they're supposed to scale. And after 10 years of creating all these NoSQL databases and having them crap and then having them get a little bit better and have people use them and then give up on them, Postgres and MySQL just stole the best parts of MySQL and made themselves better. And now we don't have to do that. It was $1 billion to figure out how to make Postgres MySQL better. And the whole NoSQL movement. Now, I'm sure we're going to get some flame wars on this one, but I think the whole SQL movement was just like a completely waste of time that eventually made relational databases better. But now they are better. They're better now. Guess what we don't need? We don't need $200,000 people. We don't need 10,000 $200,000 people. Then we don't need a bunch of $100,000, $150,000 people to support them, and another 100,000, bunch of $100,000 people, and another $50,000 people. We just need a bunch of $70,000 to $80,000 per dollar people to just make the next thing happen. So this woman that I was talking to at the Apple store, she said, I'm down. I'm depressed. I mean, I'm good at web design. And I'm like, it's okay. You're going to be fine. The entire World Wide Web is a cesspool of technology. React is horrible. Angular is horrible. These are crappy, half-baked solutions to a real problem. That real answer, like say Docker, will come in web applications. And this young woman who just graduated from college 6 months ago, I said, pretty soon, every single piece of technology on the web will need to be completely rewritten because it's so lousy.
Interesting.
You're good. Now, you're not going to get $200,000 for it, but you will be able to have a career doing the work of upconverting the crappy web technology that we use for every website on the planet today, right? And you can say that over and over and over again. Why are we using Java when we could be using Python? Well, Python's not quite there yet, but eventually every application in Java will have to be rewritten in Python sometime in the next 50 years. So that means if you're 22 years old, yes, you're not getting a job right now because we just laid off all these people from these companies. But eventually they're going to age out and we're going to need people to convert all the Java stuff into Python. And you are perfect for it, right? Those people will retire and there'll be space for you. And we're just a bit out of balance. We're just badly out of balance right now because of the lack of useful moonshot exercises in the technology space. AI, of course, is the counterexample to that. The difference is, and I don't quite understand why this happened so rapidly, that AI went from a software problem to a hardware problem pretty quickly.
Yeah.
And if there's enough money in it, hardware problems yield way better than software problems, right? And so if you look at NVIDIA and they figured out how to build these CPUs and, okay, you got 4 CPUs, then you got 40 CPUs, then you got 400 CPUs. And next thing you know, your watch has 400,000 CPUs on it. I'm like, holy crap. And then every Apple that's ever sold is more powerful than a whole semi-truck full of Intel processors. And so the hardware part of that, and NVIDIA is being very well rewarded for that. The hardware part yields fast. And that's one of the cool things, right? So I knew a guy who worked for Apple, 2007, 2008. And I said, what's the future? He says, well, I can't tell you the future because I'm not supposed to tell you the future. But if you look at what Apple's doing, you can maybe guess the future. And I said, so what's Apple doing? He said, Apple is hiring hardware people. And I'm like, what? You mean like for touchpads and stuff? He said, no, we're hiring people to make new microprocessors. And I'm like, that seems like the dumbest idea that I have ever heard in my life. Why would you do that? They're like, well, Apple's got this obsession with power, meaning that we just think the current processors use too much power. And then he said, the other thing is, Intel doesn't want to change their architecture based on workload.
Yep.
We want to make a processor that we're manufacturing so that when we detect a change in the workload that people are using, we will change our microprocessors based on the profile of the actual user code. So what's the difference between the M1, the M2, and the M3? They profiled a bunch of code. Now they're profiling AI code. And so that's what I'm saying is hardware yields faster. And the move to the ARM-based architecture with just continuous expansion and extensions and just they instrument these things so carefully about power usage for certain algorithms. And that's why Apple's got a new processor like out every week that Intel refused to innovate, right? So Intel's now out of the business of doing the innovation. NVIDIA is okay because they're making the even faster stuff, but Apple's going to slowly put them out of business because they changed their microprocessor because they have so much data about how we use these things. And as they give us AI features, then that's going to inform all their hardware profiling. And that's going to tell us what the M5 is and what the M6 is and what the M7 is. And I'm just amazed at how quickly the software came together around all this stuff. It is It is amazing. So the cool thing, it's amazing. The bad thing about it is there's not a lot of $200,000 jobs in it. There really isn't, because people are working on the applications of AI, and anyone who's learning about how to apply AI to any number of problems, I think that's a great skill, right? And that's a skill that's going to be good for the long term, because using AI is something we got to figure out. But the core like models and stuff, man, that came together fast. And so that's where you didn't need 15 years of $1 billion worth of programmers the way we did for Amazon Web Services or Facebook's database.
You're not selling it, Dr. Chuck.
That's a good point. I'm not. I'm reducing expectations is what I'm doing. But I also think that as I talk to young people, I have a son who's a young people and a daughter who's a young people, and their expectations of what they want out of the world is just different. They always say that the next generation is the first generation that's not going to be like way wealthier than the previous generation. My generation is a generation after the World War II, whatever. I don't know what generation I am, but the point is that I am wealthier than my parents were. That's for sure. And that's because I moved into a world where there was a demand that wasn't being supplied. And my entire career was technology, which was expanding throughout my entire lifetime. I started working when they didn't have fiber optic. Now I watched a guy pull fiber optic into my house that's a quarter mile long, and I'm talking to you over two gigabits.
Yeah, exactly.
And it's very reliable, and it doesn't care if it rains, right?
Yeah.
When I started, there was no fiber optic. We were arguing whether multi-mode fiber or single-mode fiber was a good thing. And they're like, well, multi-mode's better because you can plug them together and you don't have to fuse them. Then I watched this guy, and I can send you the video on this. I watched this guy like have a little box this big. It's got this microscope on it. It's got a laser on it, and it's got a polisher on it, and it's got a bunch of servo motors on it. And, this guy just sat in my backyard on his knees in my grass and fused a piece of glass that was tiny little single mode fiber. And when it was done, it sent light through it and said that fuse was bad. Let's cut another one. It fused it again and said that fuse is good. And then it put the little wrap on it, and you've got all these. It's so beautiful. But when I started, we were lucky to get like 128 megabits out of a phone line because of the impedance and DSL and ADSL and ISDN and all that stuff. But my career wasn't the internet didn't exist when I started, right? And so these are all things that led to an expansion of the demand of the talent that I had and everyone else in the market with me had. That was expanding. It's not now. The applications of things are going to keep expanding because there's always new businesses. People got to, get money, do inventory control, come up with ways to interact with their customers in better ways. And that software's never quite done, right? So that's applications versus operating systems and networks and stuff like that. So you're right, I'm not selling it. But I also think that it's all going to work out in the end because I think that the younger people will end up with a better quality of life. They will get less money, but if society can work out some of its current issues, they can live a good life. And I would say this to some degree is a Europe versus U.S. comparison, and that is that I think Europe is a couple generations ahead of the United States in that this notion that every generation has to be twice as wealthy as the previous generation. That's not quite the same in Switzerland, for example. People in Switzerland and the current generation has a good work-life balance. They walk up and down mountains, right? They work and they walk up and down mountains. America is the place where, America and other emerging economies like, India and Africa is this one that's got this obsession with every generation has to be greatly wealthier than the previous generation. But more mature cultures and economies like Europe and Iceland and all those places, they don't have this notion that that's somehow a failure. The success is if people live a happy life and they enjoy the life they want to live and they have time for work-life balance. And so, we in the U.S. have a long way to go before we accept this notion that everybody has to be super wealthy. And if your parents were wealthy, you have to be wealthier because it doesn't work that way.
I've got to ask you, Dr. Chuck, you've mentioned this before, but I want to get an update because it's been a long time since we spoke about it. You teach in university. Degree is one path, but you've got the master programmer, which is a huge benefit for people who perhaps can't go to university, don't have the money or whatever. So perhaps you can tell us, has the master programmer changed? How do I start it? Does it cost money? How does it work?
Well, so the path to the master programmer is effectively my personal curriculum that would replace a computer science degree if your goal is to become a programmer. And I have basically 10 3-credit courses. Think of it as about 30 credits. It'd be about 1 to 2 years of community college part-time. So a person could finish the master programmer path in 1 to 2 years, half-time. Meaning you can keep your job, you can take care of your family, you can do it at any age. And it's designed to cost very little. And the only cost, I'm making some stuff up that doesn't exist yet, but the vision of the master programmer is the only thing that you pay for when you're taking the master programmer curriculum is teaching assistant. And so you can, if you are so self-motivated that you don't need like a helper to bounce ideas off of, then you can just take the course and you just have to struggle and you have to learn it on your own, which is not the best way to learn. But if you want like a guide that, you've been working for a few hours and you just want a little hint or something, you go to the teaching assistant and you ask. And so I think that the credential should be free, but the thing that will accelerate your ability to go through the credential is support. A little bit of AI, a little bit of human, but sort of something that so you don't feel alone when you're learning. Maybe a cohort even. Then the idea is who is going to produce these credentials and what is going to be the credential that becomes the one that signals value in the marketplace. So we have credentials like Coursera and we have credentials like edX. Those credentials themselves are kind of like a mixed bag collection. Some Coursera credentials are valuable and signal well, and others don't. Others are just stuff that's kind of been collected. And I think ultimately what has to happen is that universities, leading universities like University of Michigan, Oxford, Cambridge, have got to come up with a way to brand these kind of sub-degree, less expensive sub-degree credentials. We'll still have computer science degrees, but I just think if you come back in 20 years and you say, you got a LinkedIn profile that has 25 Coursera badges or 3 University of Michigan badges, if we do the right thing and those credentials are well built and carefully done and carefully curated, I think that a University of Michigan-based credential in someone's portfolio will have more credibility than a bunch of Coursera certificates, Udemy, et cetera, et cetera. And so as a person in higher education who is interested in the good that higher education can bring to the world and make a little money on the side doing it, I just think that this is really important. And I have been aligning the path to the master programmer to be part of this space, even though the space doesn't exist yet, right? So I'm just imagining a future where universities are giving people low-cost credentials that are low-cost, high-value, a great price-to-value ratio. And so I'm trying to present the master programmer as one of these early. I mean, I'm just always ahead of everybody. I'm just like, in 10 years, this will be commonplace, and I just want to be the first one so that, or the second one or the third one or whatever. And I'll just tell you that on the campus at the University of Michigan where I'm at, there is a lot of conversation about this. There's a lot of conversation about this. And recent events perhaps make this conversation more important. We talked earlier about how Amazon's demand for $1 billion worth of programmers per year is not there anymore. In the United States, we have this thing called the H-1B. And it's great. It allows talented immigrants to come to the United States and gain naturalized citizenship and be part of the $1 billion attack on a moonshot problem at Amazon. Those are not so valuable anymore. I mean, it's not instant, but we don't. I mean, it was kind of like convenient way for us to extract knowledge, intellectual talent out of all these countries. The best and the brightest come to our country and stay. And it let us be ahead of every other country by a decade because their best and brightest didn't stay home. Yeah. They came here. But they came here for a $200,000 job. They didn't come here for a $70,000 job because they can get a $70,000 job equivalent in their own economy without coming here and having 3 generations of savings to pay the tuition from India to the University of Michigan. And so I also think that part of this non-degree credential is a way for us to continue to educate, because as a university, our goal is to educate and educate as many as we possibly can, which is our tiny contribution, hopefully, to making the world a better place. If I was a medical doctor and I ran a hospital, I would say to you, my job is to make the world a better place. And I'm trying to figure out how to make hospitals work better so I can make the world a better place. Well, my way of making the world a better place is educate better. And so I think that we're going to start seeing not just like, ooh, that'd be a nice idea, Chuck. That's pretty cool that you can educate anyone anywhere in the world and you can assign a University of Michigan credential to anyone anywhere in the world at low cost.
Be amazing. Yep.
I think in 5 years, you're going to come here and you're going to like, any university that's not doing that is a fool, because just the nature of, especially United States, higher education, things are changing. Again, I'm kind of taking it through a technology lens, right? But technology is where most of these people come to the United States to get H-1B visas. And as that becomes less and less valuable, and it's not that people can't get H-1B visas anymore. The problem is once they graduate, the companies won't then sponsor their H-1B employment because there's so many people from the United States of America that can take those jobs. And it's a pain in the neck to do H-1B paperwork. But if it's your only choice, then companies do that. So I'm just saying that the demand market internationally is changing. And so for me, the master programmer, sub-degree non-credit credentials are all part of like a future. I'm envisioning a future world. And how can I, as an educator, educate in that future world?
It's amazing. What have you got today, though? So let's say I want to start today. We're going to repeat some of the stuff we've done in our previous interviews, but just for people who haven't seen them, are there courses available, and what are the courses?
So the path to the master programmer, I have spent the last decade on Coursera building what I considered intro classes. And so when I would get done with one intro class, I would go build another intro class. And when I get done with that one, I would go build another intro class, because you hear me talk a lot about welcoming. I want to say, you want to learn some database? Welcome to the most accessible database class on the internet. You want to learn about request response cycle? Welcome. Do you want to learn about the internet? Good. And so my whole goal has just been to welcome people in. The problem is I have 5 really good courses on Coursera: Internet History, Python for everybody, Web Applications for everybody, Django for everybody, Postgres for everybody. 5 really good courses that most everybody with enough patience can take. They're not prerequisites to one another. And so I would meet students that would take all 5 of those classes, and they would say, what job can I get? I took your class. This is your curriculum. I mean, this is your degree. Yeah. I took 5 of your classes. It's the degree of Dr. Chuck / Coursera. And I'm like, you can't get a job with that stuff. That's nowhere near enough. And then I'm like, oh, wait a sec, Chuck, what are you saying? You're like, you spent a decade of your life building all this stuff, and now you're admitting that they can't get a job from your stuff. They could get a promotion from my stuff, but they couldn't get a job, right? If that was the only education they had and they're 19 years old, I can't tell them how to get a job with all 5 of my courses. So that's where the path of the master programmer comes. And the key idea is to come up with the shortest set of curriculum to get to the point where they're ready to hire. And so then I said, okay, I got to make it a short curriculum. I can't make it a long curriculum, because that's what a computer science degree is a 4-year curriculum with way too much stuff in it. And so I came up with, originally it was 4 courses, and now I came up with 5 courses. And the 5 courses and the key to these courses is these courses have prerequisites, and these courses build upon one another. And I'm not expecting 1 million people are going to finish all the courses, because they're going to get more difficult. They're not just more beginner courses. They are advanced courses to the point where the last course is going to get you ready to work. And so here's the courses. The first 5, which are all beginner courses: Python, Django, PHP, Postgres, and the internet. Those are just kind of take them in any order. Then the next courses are C, but it takes prerequisite of minimum Python. Then the one after that is hardware. And that's why I've got these cameras in my office so I can hold on. I'll show you. That's camera 5. So now that's camera 5. So someday when I'm teaching my hardware classes, we should have got some hardware here. I want to be able to teach a class. And you probably have done this in some Cisco stuff, right? Where you grab a router and you're like, and then you plug a Cat 5J into this thing, and then another thing goes in there, and the packets come out. And so, a hardware class. So there we go. That's my handheld instant cam. Okay. And here's my wide angle shot, and then back to my MOC, middle of camera shot. Great. So here we are. So hardware, and I'm building my home studios so I can teach breadboarding in my hardware classes. Then I decided on a JavaScript class. I'll come back to that JavaScript class in a second. And then a Java class, and then a internship class. And the internship class is a kind of a blend between work. I chose Java over C++ because it's free. And I can't in my heart prepare Microsoft people, because that's not a bad job. And if you are that, then great. You're probably making a lot of money, but open source, free, open stuff, that's what I teach with. So the one class that I added to the Path to Master Programmer was JavaScript. And if you go back to all my stuff I talked about 4 years ago, JavaScript wasn't in there. And JavaScript wasn't in there because I thought that JavaScript was a wretched garbage dump of software. Not to put too fine a point on it. I feel like React is wretched. I feel like Angular is wretched. I feel like Svelte is wretched. I feel like Ember is wretched. Wretched, right? Go back. Backbone. There's all the things. jQuery was good, but we don't use jQuery anymore because the browser's to the jQuery. But here's the deal, and this is the first lecture of my JavaScript class, and that is, the time is coming when we're not going to use any framework in JavaScript. The framework-free moment, just like jQuery. I mean, it took me a long time to let go of jQuery. I loved it so much. Thank you, John Rezick, right? jQuery made browsers safe for programming for 15 years. But the time has passed, and it was just a crutch. It was a crutch to understand use cases, and a crutch so that we could write software without waiting 15 years for the browsers to catch up. It may not seem like it, but React is the exact same thing. React is a crutch because the browsers are not yet capable of meeting our needs and use cases, except that the thing that will destroy React is on the horizon, and it's coming towards us. And it's called web components. And what web components are, and what React is, and what Angular is, and what Java Server Faces was before it in the server, was the ability for us to capture our application functionality and render it as a single tag with a few attributes. So think of all the templating languages that have come along: Velocity, Java Server Faces, Timeleaf, Mustache 2, all those, Haml, right? Those are all ways to take data and transform the data into HTML. And the way that the latest things are happening are not just transporting data into HTML, but transforming data into HTML in a way that's reactive, which means you can have the tag sitting there showing a little card with some, like a status number or whatever, and you can send a new little notification to that piece of thing on your screen, and it reacts to it without you having to redraw the whole page. So if you look at what React and Angular did, is they worked very hard to bash that into your markup. Meaning there's a thing, it stays, and it's notified, and something changes without you having to change the whole page. They were web component frameworks. They're just really previous generation of web component frameworks. And the other thing that was bad about all those things is they were inexorably bound to Node.js. And again, the people can yell at me in your comments, right? And they're going to. I'll just say Node.js is the world's most wretched server environment, just like NoSQL is the world's most wretched way to do databases. But Node.js taught us something. Node.js taught us about dependency management for JavaScript applications. And any programming language to be grown up has got to have a dependency management system. In Java, we call it Maven. In PHP, we call it Composer. In Python, we call it pip, which means you can't really use something professionally until it has dependency management. Node, which is a server program, gave us NPM. And then what it did was you would install all these dependencies, which are libraries written by people, and then it would actually sort of, at runtime, form these libraries into something usable by your application. And so until 3 years ago, you had to run Node to create a network of dependencies in JavaScript so that you could just use somebody's dang library and have it ready for you to use when you start writing code. But you had to use Node as your server, which is a wretched server because it's single-threaded, because JavaScript is single-threaded, blah, 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 blah. So Node is wretched, but it was the only way to do dependency management. In the last 3 years, and React has kind of been leading this too, so the React people have been improving to the point where you don't need to use React in a Node application anymore by pulling the dependency management of Node out into a thing that you can do. But then you also have to do this web components management that's kind of React. Dependency management has been pulled out. Well, they have kept decoupling all that goodness, the JavaScript goodness that Node and NPM gave us. They have been decoupling that and generalizing that into a thing called ES6 build. And what ES6 build is a process that has nothing to do with any web framework. It's just files. It's like make for JavaScript libraries. And when ES6 build is just like, why couldn't we have had ES6 build 15 years ago? And then we wouldn't have to do much of this stuff. But it just, again, innovation, iteration. But at some point, you get something that's really nice. So, ES6 build, framework, it's web server independent, language independent, but it lets you build a really beautiful set of dependency injected JavaScript with whatever libraries you want. But then the browsers are starting to implement these template tags and custom components and how you get the custom components to be built. But then you have a dependency management thing, and then you have this caching and tree shaking and all this stuff to the point where you just write stuff in JavaScript, you ES6 build it, and then you just hand it to the browser, and then you code in the browser. And all of a sudden, all the affordances that were hard to do in Node, in React, Node, all these other guys become easy. And then we have the one universal way to write web. We won't argue whether it's Angular or React in a few more years. They'll just be old. And it's going to be beautiful. And everyone will write reactive code. And they won't even be trying. It'll just be second nature. And so that's why I have to teach a JavaScript class. And that's why I used to think I wasn't going to teach a JavaScript class. Because JavaScript went from a garbage dump of software libraries that was always under attack by a new software library to the one true way. And now, one of the things I do is I don't teach classes that don't last a long time. Like if you teach a class on IP, at least IP4, it's good for a while. You teach a class on C, it's good for a while. And I don't like teaching things that are kind of like just yesterday's flavor of the month ice cream. Like I'm not going to teach a class on AI, not for a long time, because a bunch of people that I know built classes online for AI, and the moment they finished it, they were revising it because it's too fast. So I'm not going to teach a JavaScript class until I believe that I'm teaching a class that will barely need any changes for 10 years. And JavaScript is coming to that point. So now JavaScript becomes a foundational skill that I can teach. And there will be new libraries and there'll be new dependencies and all that stuff. And you can learn that on the job. But I think that JavaScript is really growing up and has really grown up in the last 3 years. And I think that we're going to see a lot of beauty in JavaScript going forward that never has been there. I actually gave myself a break from course development because C took me 4 years. And so I'm letting myself be a software developer for a year or so because I build all these courses with a technology that is of my own making.
Yeah.
And I want to rewrite some of that technology before I do my next course. And what'll probably happen is that I will teach the JavaScript course next because every semester at the University of Michigan School of Information, I teach a web development class. And that's been a Django class for about 4 years. And that's solid. It's a great class. It's well done. And it's on Coursera and edX. And I just want to start over. I want to build a Django plus JavaScript class because you have to have some back end for web services and stuff. So over the summer, I will begin to build JavaScript for everybody. It'll be jsfree.com. And the way I build stuff is I build it in GitHub first. And I just start populating that jsfree.com webpage with recorded lectures and PowerPoints. You can kind of watch it grow. And then hopefully by fall 2025, September 2025, then I will force myself to teach that class, which means anything that's not done, then I'm going to have to do it. So I should have a complete course by December, and then I'll probably iterate one more time, January through May, and then I'll have a MOOC somewhere. And so then the JavaScript part will be, and part of the reason I switched hardware in JavaScript is because I can teach JavaScript in our curriculum. There's no call for hardware class at the School of Information where I teach. There is a call for a good JavaScript in a Django class. And so if I can sort of double dip by teaching my day job class and use all my students as beta testers for my crazy ideas about how you should learn JavaScript, I'm going to do that. I'm going to double dip. I'm going to double dip and then leverage my on-campus teaching. And then that'll be the class I'll be teaching probably for the next year. And so that accelerates it because I'm doubly motivated then not to both build a online class and a on-campus class at the same time.
But these courses are free, right? I don't have to pay for these courses.
So, yeah. That's one of the things that I'm trying to convince my colleagues to think about teaching and developing course content the way I do. Because I am literally the most prolific and successful online educator on the planet. I have 6 Coursera specializations and close to 25 classes. No one comes close. I have more classes and specializations than most universities do on Coursera. But my courses are also on edX too, and they're all free because I also host them. And that's why I'm taking a little time to revamp my own infrastructure. Because when I build a class, I approach it like a publisher would approach it. By this time next year, I may have a JavaScript book because I'm like, I don't like any of these books. So step 1 is to write a book. And so for me to imagine teaching a 15-week class that's going to go online, if I tell myself that writing a book is a 2-month task I've got to do so that this class is great, I'll just write a book first. And I will. Because I know that this course is going to be good for 10 years. And if I have a textbook, more students will be able to learn because of different learning styles. Some students love a book. Some students love video. Some students love hands-on. And so if I build a book for the class, then I've got 25% of the students, that's the best way for them to do it. And so I may, by fall 2025, not that long from now, I may have written a JavaScript book because I want to teach a JavaScript class. And so very few faculty think to themselves, well, I got to teach a class next fall. So I'm just going to write a book right now. End of story. And so my lead times on classes are just very different than most faculty. And what I'm trying to do is build software to make that easier and easier and easier for other faculty members to do, build evergreen content that lasts longer than one semester, and then make sure it's harder up front, but it makes your job a lot easier in the out times.
I love this. I mean, you've got millions and millions of students. You're changing the world. And I really appreciate you doing that, Dr. Chuck. Rather than charging some stupid amounts of money, you're making it free for people who can't afford it to change their lives.
Yeah. Free first, make money later.
Yeah.
As I was told by a good friend of mine, one of our graduates had a startup. He said, the most important question in a startup is not making money. The most important question in a startup is whether or not you have a good idea. And so if you spend the first 6 months of your startup thinking about nothing more than how to make money, then you completely miss whether it's even a good idea or not. And if it's not a good idea, you just wasted 6 months.
Dr. Chuck, I think we've said enough. I really, once again, appreciate you giving to the community, changing lives. Thank you so much.
It's an honor, and it's always fun to talk to you, and I look forward to our next conversation.